Hey, here's a video for page 19. We're going to do the odd problems on this page. So 1, 3, 5, 7, 9. Find the coordinates of the local maximum or local minimum point for each quadratic curve and state the nature of this point. First of all, I'm going to show you how you would do it without calculus, without derivatives. And the only reason I'm showing you this is because if they don't tell you to take the derivative, they can't really force you to use derivatives to find maximum or minimum points in math studies because they allow you to use a calculator. And you remember second calc max or second calc min? Well, you can always use second calc max and second calc min to find a minimum or a maximum point. So now there's one case you can't, which is on rare problems they're going to put a variable in here and you're not going to be able to put it in the calculator, okay? And so for a couple of the problems, you are going to have to take the derivative. And most of the cases, they're going to force you to take the derivative by saying, please take the derivative, okay? Now, first I'm just going to show you how to do it, how you always did it. And here's the graph of this function here. It's what we always call the blue function because it's, just the regular function. And if I wanted to find the minimum point, obviously there's no maximum point here, but if I wanted to find the minimum point, which is about here, I could just do second calc minimum, which is option 3 here. And then left bound, I can just hit enter there. And then for right bound, I'm going to move the cursor over to the right side and hit enter again. And then the guess, it doesn't matter. Just hit enter for guess, and the minimum is at x equals 2, y equals 6. Okay, so the answer for this one was 2, 6. And it was pretty easy. We found it using methods that we already knew before this whole chapter. Okay, but of course that's not exactly what we should do because we are trying to learn things we know from the chapter, and they are going to force us to do things from the chapter when it comes to test time, right? So what we're going to do to use what we know from the chapter is, if we're finding a local maximum or minimum point, we want to find the derivative of the function. So x squared minus 4x plus 10, the derivative would be x squared, 2x minus 4. And then we're going to say, okay, this is the derivative function, which we write y dash. And the derivative function, if we put it into the calculator under the y2, we can find when the derivative is equal to 0 by using the table. And if we look at the table, we can see that, hey, look, the red function is equal to 0 here, and it happens at coordinates 2, 6, which is the same coordinates we found by second calc min, but we found it by making a blue function, a red function, finding the red function at 0, and then seeing that it happens at 2, 6. Okay, now if you didn't have a graph and you were trying to figure out if this is a minimum or a maximum, you can kind of look at the surrounding y values, right? So this is a 6, the surrounding values are a 7, that means it's lower, that means it's a min, right? So I could write that I've classified this one as a minimum. Let's do number 3 the same way. So 3 is this function here, x squared plus x minus 3. If we wanted to take the derivative of that, we would get y dash equals 2x plus 1. And y dash equals 2x plus 1, if we put those two functions in the calculator, so the first one would be x squared plus x minus 3, x squared plus x minus 3, and then the red function would be 2x plus 1, 2x plus 1. We can look at the table, and then we can look when the red function is 0, and I see no zeros here, but I do see a transition from -1 to 1 here. I bet if we change the step size to 0.1, we might be able to find 0 here. And we do. It happens at -0.5, comma, -3.25. So that is the point that is a local minimum or maximum, -0.5, comma, -3.25. Okay, so that is the minimum or maximum point, if I look at the surrounding points, do you see how the surrounding points are less negative? So that means they're going up. So this is also a minimum, isn't it? And again, you could, like, if you graph it, you could probably see that, yeah, it's going to be a minimum. Okay? Let's look at number 5. Now, remember, I always advise you not to graph the red function because it might be confusing. Okay, number 5. So we got 3x plus 11 minus x squared for the blue function. And let's find the red function here. So the red function for this would be 3, because the derivative of 3x is 3, the derivative of 11 is 0, and the derivative of negative x squared is minus 2x. So it would be y dash equals 3 minus 2x. So let's put that as the red function. And for the blue function, we're going to put 3x plus 11 minus x squared. And then I'm going to look at these at the table. Oh, and I forgot to change it back to step size plus 1, but I can do that by doing second table set, 0, 1. And now I'm going to do second table again. And I don't see any zeros here, but I do see a transition from positive 1 to negative 1. Maybe it's in between those. So I'm going to do a plus 0.1 to change the step size. And there it is at 1.5. So at the point x equals 1.5, comma, 13.25, there is a minimum or a maximum. And if I want to see if it's a minimum or a maximum, I can look at the surrounding points, and do you see how they're slightly smaller? That means that this is a maximum. Okay? Let's look at number 7. So number 7 is that one there. Now, if we wanted to find the derivative of x minus 3, so the first thing I'm going to do, I'm just going to rewrite it. I'm not doing the red function yet. I'm only rewriting the blue function in a different way. I can't take the derivative of two things multiplied together in math studies because I've never done that kind of derivative. So what I'm going to do is, I'm going to do FOIL. I'm going to multiply x with x. I'm going to multiply negative 3 with negative 7. That gives me plus 21. Then I'm going to multiply the two middle ones, plus 3x. And I'm going to multiply the outside two ones. That'll give me minus 7x. So that'll give me x squared minus 4x plus 21. Okay? And that's the blue function. Now I want to find the red function by taking the derivative of it. That'll give me 2x. So the derivative will be 2x minus 4, because the derivative of x squared is 2x, and the derivative of negative 4x is negative 4. So now I can put these two functions in here. The blue function, x squared minus 4x plus 21. And the red function, 2x minus 4 minus 4. And I will check the table, and let me change the step size to 1 because I forgot to change it back. And I can see there's a 0 here. So at 2, 17, there is a minimum or a maximum. 2, 17. Is it a minimum or is it a maximum? Well, if I look at the surrounding numbers are bigger, so it must be a minimum. Okay? And just one last one. We're doing number 9 now. Same thing. We can't take the derivative of this because it's two things multiplied together. So first, we'll rewrite it as x squared plus 4x. Then we'll take the derivative of it. The derivative of x squared is 2x. The derivative of 4x is plus 4. And then we'll put both of these in the calculator. The first one will be x squared plus 4x. And the bottom one will be 2x plus 4. 2x plus 4. And if we do second table, we can see maybe that, oh, there we go. So the red function becomes 0 at -2, -4. So that must be the minimum or the maximum. How can we tell if it's the minimum or maximum? If we look at the surrounding points. So if we see that the surrounding points are less negative, that means they're bigger. So this is actually a minimum. Okay. So this goes with this problem here. That was number 9. So we finished all the odd ones there. Let's go to the end of the page. It talks about how to do some of the problems from the next page. So we'll put this, go over this example with page 20 then, which is the next page.